Welcome back, everyone. We are now in the reassembly phase of this antique Briggs and Stratton engine. And as you can tell, I have painted it. Unfortunately, I just deleted all the footage of that. But it really wasn't that big a deal. So how I prep the block is I first removed any residual oils with brake cleaner, just make sure that it's all washed away. I then hot soaked the engine in my laundry sink with liquid Dawn dish, a lot of Dawn dish detergent, which helps to suck the oil out of the porous cast iron. And then I took it out of the hot water and I dried it down. The thing about hot cast iron is water evaporates rather quickly off of it, so that's why you want a hot bath. And we did the base as well. So the whole engine's painted, except for, of course, we still have to do the front cover, the shroud, which is cast iron. That has to get soaked in evapor-rust before I will touch it. I also, I've just started putting the valves back in. This is a pain in the ass. Now, I actually have a valve spring compressor that one of my friends lent me. I have to mail it back to him. It's not the right tool for this engine. It's not going to work. But I'm going to I'm going to try to do one of these. I already did the exhaust valve. Now we're going to try to do the intake valve. And I'm going to show you. This is a pain in the neck because of the design of the valve retaining collars. Let me try to get the camera so we can actually see what's going on in there. It is a pain. It's kind of like a walk and chew gum kind of deal. And you want the follower to be retracted. Good. Okay. So then we're going to take our valve and put it in the correct way. So we should have two collars, or collets, and I believe they are in this bag here. One of these bags. Yeah, I got two collets. Those are the retainers. I've got the valve already in the valve stem guide. I've lubricated the valve stem guides with oil to kind of pre-charge them with lubrication. And we're going to put these in like this. So anyway, the paint that I used is Duplicolor Racing Green. It can't be found locally. I tried and tried and tried. I could not find it anywhere near me. So I had to order it off the internet. And that was entertaining. Actually, no, that was fairly non-eventful, but definitely kind of wish I could have gotten it locally. So I went to my local auto parts stores, and they were bewildered. They're like, Hunter Green engine paint. Huh? Because that's what I was looking for, Hunter Green. And as it turns out, I believe it's the same part number. So the same color. It's just sold under Racing Green or Hunter Green. And if you look at this doesn't look any different from your typical Hunter Green anyway. So they're like, what kind of Honda does that go on? I'm like, it's not for a car, it's for a tractor or an agricultural application. They didn't understand. I live in a city, so they're like, what? What kind of car does that go to? Seriously, they asked me that. Like, what kind of car is that for? I'm like, it's for a 1937 Briggs and Stratton. Good luck finding that in your computer. Anyway, so what do we got? So I've got the valve back in. I've got the spring in. Now what I need to do is I'm using these large flat blade screwdrivers as little ramps, okay? This is really not the right way to do this, I'm telling you. There's an actual Briggs and Stratton part number for the tool that I need that is for this application, and well, would you know it, I couldn't find it at my local hardware store. Anyway. So I got So what I want to do is I'm going to arrange these large screwdrivers in a V, and that's to keep the collets in position as I rotate the valve. So just bear with me here. I got to push that valve back in. There we go. Okay, this screwdriver slipped out. There we go. So this is how I'm doing this. It's not easy being green. See if we can get a good focus on that. So here are the little collets. They are tapered. They're made of a hardened steel. And we're going to drop them in one at a time. There's 2 of them. There's one. Now what's going to happen is they're going to fall out of position. And then I'm going to start swearing profusely. Yeah, this one already did that. It just said, you know what? I don't want to go there. Screw you. I'm going to try to work. There we go. I worked it in with a screwdriver a little bit. Almost in. Not fully in. Up. You suck. Then we take our magnet. We pick it up. We try it again. We got to do this twice. Well, 4 times. We already did the exhaust valve. I did that off camera. I thought I had a process that would work. And... okay. I had my girlfriend in here earlier. She was trying to help me by holding the screwdrivers. It wasn't working out. So let's try to get one in. You can't get your fingers in there. Come on, you. The thing is, to get one in, you got to pull the spring back a little bit. And by doing that, if I get one, it's going to fall out when I get the second one. So it's kind of a lose-lose proposition, you know? Come on, you. Come on. There we go. What an ordeal. I tried doing this with a pair of curved pliers. Now, that looked promising at first. But ultimately, it was for naught. Okay, so I got one collar that's basically in situ. Now, if I could have gotten, yeah, see, it takes an almost acrobatic approach to mechanics. And, come on now. Try it again. If I could just get that screwdriver to stay right where I have it and not budge. And then the valves keep wanting to pop out. Yeah, this is not going to work. I'm not even sure how I got the exhaust valve in, to be honest. Okay, let's try it one more time. It is a pretty engine, though. I mean, you look at the casting on this engine. It is a beautiful piece of machinery, if I do say so myself. Okay, so there's, yeah, that one's in. Now, if I could just rotate the valve. So what I do is I turn the cam, if I can. Well, now I can't because there's spring tension. Where's the camshaft? Yeah, see, now that it's under tension, it's like, yeah. No, that's not what I want to do. Okay. So we need to figure out a way to rotate the valve, oh, like that, kind of like that, but in a way that doesn't cause that collar to fall out. There we go. There we go. We're getting there. Okay, let's get the second one. See if we can't kind of work it in. On this side, like that. Shit. We got it, we got it, we got it! It's in. Oh my god. Is it in though? Well, it depends on your definition of in. Actually, this one doesn't even look... It's not really... Well, it's in. This one's incorrect. Yeah, okay, it worked. I'm looking at the exhaust one though, and I'm not liking what I see. Okay, so we can... Yeah, okay. It just doesn't look right to me. Like it's kind of not all the way. I mean, it's locked in though, for sure. Yeah. Oh yeah, it's locked in. So we got it. All right, we got it. Oh, let's crack open a beer. Well, I don't drink, so if I did, I would crack open a beer. Okay. Now let's turn that. Okay. Yeah, it's all right. It's good. It's good. It'll live. All right. Now. So now we're going to get ready to put the crankshaft in, but I've got to find that punch mark. Okay, so this right here appears to be, see the punch mark? So that's got to be either top or bottom dead center. That's going to be top dead center. All right, so we're going to get our crank. Apply some oil to the bearing. I'm going to clean this crank off first with a clean rag. We're going to get any dust bunnies off of it. Make it pretty, all pretty. Once we get this engine running, we're going to have to change the oil a couple of times. So we got our punch mark here, and that lines up. I did say I was going to oil it. We're going to oil the bearings. Okay. Some oil on those bearings. Okay, so we're going to drop that crank in. Like so. Making sure to line up those two punch marks. I'll show you what I mean in a minute. Grab the camera here. Okay, so there's going to be two punch marks. Where the fuck are they? Alright, there's one. Okay, there we go. So right there, there's a mark here, and there's a mark here. Alright, we got to get that to slide in. Is it in? No, we're one tooth off. Let's try that. Let's try one more tooth. one tooth off. Nope, that's it. So this should be our top dead center point right here. Okay. I don't think that's right. I'm going to double check my work. So that'll be intake stroke, bottom, compression stroke, fire. Okay. So this flat spot, that's where our ignition source is going to happen. That's where the ignition is going to happen. Goes down, power stroke, exhaust opens, exhaust comes out, rinse and repeat. So intake, okay. So according to the mag plate, which is over here, the ignition trigger occurs at what appears to be the 1:30, 2 o'clock position, which about lines up with what the mag plate looks like. So what I'm trying to say is the ignition trigger is not located in line with the top dead center position. So it's not going to be right here, it's right over here. And it fires, it should be a couple degrees before top dead center anyway. So there you go. So the engine is now timed. Yep. Let's get our piston. I'm going to squirt a little oil down that bore. Okay. Gonna get that nice and lube. Make sure the piston's wiped down nice and clean. There's going to be a little bit of lint on there, but that'll burn off. Okay. Alright, as for direction, I'm going to take the connecting rod apart. There's some casting marks that we actually have to pay attention to. Those are supposed to face the flywheel side of the engine. So let's make sure we do that. Let's take this off, make sure we don't lose those spacers. Now I looked at the service manual, or what little service manual I could find. I'm gonna pump this thing full of oil too while we're here. Get some oil down in there. All right. You don't want this engine to start up dry, do you? I don't. Okay. All right. So let's get this back in there. So there's some casting marks. They're right here. There's one there. And that faces the flywheel. Okay. Now I actually bought a ring compressor. And it was from Harbor Freight, and it was not small enough. So I'm thinking we're going to have to just kind of tap this thing in. I'm going to grab my my mallet. Okay. But yeah, I did buy a ring compressor, and unfortunately it just wasn't going to do the job. So you do it gently, one ring at a time. Use your fingers. It's a lot easier with the right tools, like everything else in life. Let me show you what I mean. This is the ring compressor I bought, and it sure tries hard, but it just doesn't do the job. I mean, I am cranking this sumbitch, and yeah, it just can't go. It cannot shrink to the size it needs to. So. Okay, I think I got it. Almost. Okay, before you drop the piston, and you want to make sure that your ring splits are, your ring gaps are in the right position. The oil ring gap is here, so we're going to crank this lower one like probably 180 out. And this top one is going to go here, over there. You don't want them lined up. If you do, it could lead to an oil consumption problem. Okay, I'm going to try something different. This is, I just thought of this, and I'm sure I'm not the first one. What I'm going to do is I'm going to use zip ties to hopefully serve as ad hoc or AirSats ring compressors. Let's see what happens. Get them nice and tight. Okay. Then one over here. Nice and tight. Okay. And just try to knock it down. Well, it's moved it. I'm a freaking genius. So now on the bottom end, we want to make sure that our connecting rod is lined up correctly. Okay, we got her timed. So now I'm just going to get the connecting rod and crank lined up. Again, double check those punch marks. Yeah, that's as good as we're going to get her. Okay. Now we can put the bearing cap in. I'm going to squirt some oil down in there. Be generous with that oil, guys. So we're now at a point where we can finally put our bearing caps on. Remember, the casting mark goes towards the flywheel. That's this mark right here. And we'll put our shims in. Flywheel side is here. Once again, oil is good. I do not have torque specs, and I noticed that there's we are missing. There should be like a brass cap that goes over the bolt holes, and I just don't have those. So, unfortunate, but such is life. We know this engine's been apart before. You know, one thing we never figured out was whether or not for sure it was rebuilt or not. We never did figure that out. I have suspected that it's not a rebuild. So it's been apart for one reason or another. We don't really know any history on this motor. We don't even know what it was used on. So I'm just going to do my best to get these evenly tightened. You know for a fact that many of these engines were serviced over the years without any torque wrench involvement. And they ran for centuries anyway. This is a big step though. I mean, we have come a long way since we had this engine first torn apart. I don't want to over tighten anything because we're dealing with old alloys. So as long as they're relatively equal tightness, it should be all right. Okay. All right. So we want to get plenty of lube in, on, and around that. Here, let's get some 10W40 here. We'll just put a little bit of that in there, and we're there we go. A little bit of that. And I'm going to crank the crank. Here's my flywheel. I might just pop the flywheel on for a minute. See if that'll grab hold. Or better yet, why don't I just use this rag? I can crank it. Ugh, so let's just double check our timing here. So this is top dead center. Okay. Ignition trigger is where it should be, right here. Okay. Intake, stroke. Yeah, there she goes. Intake, compression, fire, exhaust, power, exhaust. Not bad. I think she's gonna run, but she's coming along, guys. Now, for the crankcase breather, I did this off camera. The crankcase breather I filled with some grade 1 steel wool, which I wadded up and I got nice and coated with oil. And that is our new crankcase breather. The original element was of a very similar wire mesh that we could not save. I don't even think you're supposed to try to save that, but we tried and failed. At this point, we could mount this on the engine base, but I'm not going to do that just yet. Still have a lot of work to do before we really get that far into it. But I'm so excited. We're going to get this engine running, and I'm going to put it on the mantle when it's running. That's the plan. Okay. So I've just gone ahead and I've cleaned up the oil sump bolts, and what we're going to do is we're going to mount the oil sump at this point. Okay, so I got myself an order of parts from Briggs and Stratton restoration parts specialist, antiquebriggs.com, I believe it is. And so from them I was able to order a brand new old stock gasket for the oil sump. You've got a head gasket, and we've got a rocker box gasket. A valve spring box gasket. So here is the engine base gasket. We're just going to get some oil on this. I got some motor oil in here. We'll use that. Just kind of get it nice and wet. Now what you want to do with these paper gaskets, and this is not asbestos like the original one was. This is a slightly newer part. So this would have been made as a stock replenishment part, probably in the 70s or 80s. It does not appear to be of the original composition, and I keep dropping it because it keeps slipping out of my fingers. But we get this gasket nice and wet with oil so that it will easily be removable should we have to split the case again. So the oil sump should go this way because you've got the holes in the front for the engine shroud. Just drop the block on here. Now there is nothing else we need to do from below. I've already cleaned the gasket mating surfaces, by the way, so we don't have to do that. You don't have to waste your time with that. Something. Can you guys remember what very important part I forgot to put on? Well, let's just say if I were to continue on with this, this engine would seize very quickly. What did I forget, folks? Anyone? Class? Anyone paying attention? What did I not put on? I'm glad I remembered to stop what I'm doing because I need an oil pump. You need the oil pump for proper lubrication. Get it on the rag there. Okay, where's my oil pump? I had it disassembled. Here it is. Already cleaned and disassembled. Yes, folks. It's kind of important to have that. Now the question is, well, how does it go in? I should have some instructions actually. Let me just confirm. I have the paper assembly guide right here. Oil pump. Let's see if this has anything on that. It sure does. Okay, so it says the oil outlet should face, so if we're on the let's see. The oil pump is assembled to the crankcase with two bolts and lock washers and is operated from an eccentric on the cam gear. An inoperative pump will result in insufficient lubrication. Okay. So I'm looking at the drawing here. So the oil outlet should face, with the cam gear in the back, it's going to face to the right. And this little flag here is going to face to the left, like that. So this goes together like this. Just like that. Okay. So as I'm sliding it in, this outlet is going to face opposite direction of the cam gear. Oh, that makes sense. That's pretty straightforward. Should we prime it? What do you think? What I'm going to do is, while it's upside down, I'm going to pour oil into it. It goes like that. And I got my hardware here. I coated everything in clean oil so that it wouldn't rust. So far, so good. Okay. Yeah, that is correct. When we had this engine apart the first time, well, when I tore it apart, initially, what I found was the oil pickup screen was nearly totally blocked. And I do mean totally blocked. So what I'm going to do is I'm going to work this pump a little bit back and forth. I'm going to try to anyway. Make sure that it's good and primed. See if we can get this screwdriver in there. Maybe not. Okay. Well, the oil's getting in there. Somehow through the check valves, the oil should be getting into it pretty easily. There we go. Okay. And while we're in here, why don't we just go like this? Just kind of douche everything with a little bit of Baghdad's finest. Okay. Can't believe I almost assembled this engine without an oil pump. Wouldn't that put egg on my face? A seized engine on my workbench. Carpe the engine means seize the engine. That's about right? I think so. Yes, sir. Some of these you can only get with wrenches. Oh, that's a really coarse threaded screw, isn't it? Like 5 turns and you're in. Damn. Really makes me anxious. I got my Miata parked right behind me, and anything that goes flying off this bench is going to hit that poor little car. So, it's got me worked up here. Come on, baby. Get out of there. No, huh? Yeah, you really got to do these engine base bolts with a wrench. Yeah. A 9/16 wrench. Let me go grab a 9/16 wrench. Okay. Well, that was fun. And as with any gasketed surface, you want to make sure that you just get them good and snug before you tighten them so much that the heads break off. Just get them good and tight. And then that's when you send them home. You don't want to go too tight. Remember, cast iron engine from the 1930s. So this is where we're at. The engine is mostly assembled. The carburetor is mounted. I hooked up the governor and bell crank assembly as it's explained in the book. I may have to reverse the bowl cover, or the float bowl chamber cover. I think this is on backwards. It goes the other way. Because if you look at where the fuel tank mounts, or how it mounts, the fuel line comes back around this way. So that makes sense. I decided not to paint the valve cover for now, although I may reverse that decision later. I just don't think it needs to be painted. I like that. I might take it back off and lacquer it. The clear lacquer. Such a beautiful, beautiful engine. I mean, not the most beautiful as engines come, but definitely up there. And one of the best looking ones I've had. You know, the engineers were very artistic in their designs, either deliberately or not. Just the way everything kind of flows together and has a very Art Deco look to it, which I really like. Yeah, just a beautiful motor. Absolutely. Yep, everything went together just fine. Everything's lined up as it should. I don't have any concerns at this point. Yeah, once we get the the bore is very tight. Those rings need to really work their way in. The first couple hours of operation, this engine is going to be pretty tight, and eventually it'll loosen up to where it'll be more acceptable. But the carburetor is all ready to go. It's cleaned, reassembled, new gasket. Yeah, this thing is such a beast. Look at that. And the paint, oh man, I love the paint. I love the color. It just, it's so unique. So apparently, and I checked the manual, there are no rubber seals or anything like that, no leather seals for the crankshafts. It's designed so that the oil is to flow through and out. And these little metal dealies, like Homer Simpson, metal dealies, these dealies here are really just to prevent oil from splashing out and nothing more than that. But the oil is supposed to drain back into the crankcase through some check valves. That's it. That's just how it works. Yeah, I know. I was surprised too. Well, anyway, I gotta go. So this is it. I don't know what this casting mark means. MC. If anybody knows what that means, I'd love to hear from you. MC. Okay. So I've put the components in evaporust. The mag plate and the shroud. And I'm going to have to rotate the parts around. I only have a gallon of the stuff. The auto parts store had 1 gallon left. So, that's the same gallon, by the way, that they've had for 2 weeks. Ask me how I know. Because I went there 2 weeks ago, and they had a gallon. And I said, do you have any more? And they said, well, no, we have some on order. And I said, okay, then. I go back 2 weeks later. They have 1 gallon. So I just went ahead and I bought it. I said, screw it. So, okay, so I've got the horseshoe. Apparently, these are hard to come by. From what I've heard, these are... One of my commenters mentioned that these are hard to get in working condition. And it turns out, this one, I checked it with a multimeter, and it's coming up Millhouse. So, we're going to replace the spark plug lead. I have a reproduction spark plug lead on order, and it will match what was originally on the motor. That's what this is. This wire is in really bad shape. The rubber has totally disintegrated inside. You can see it's, yeah. So the rubber's bad. We're going to replace it. Not a big deal. It's $7. I got a decal set on order, a period correct decal set for this engine, although it's not for the Model A. It is for, I think, a Model BB or something like that. But not for a Model A specifically, but it will do the trick. It will have the correct logo on the shroud, which is what I'm going for. What else? Okay, so the spark plug that was in this engine, I want to show you something. This is baffling to me. Now, this is a Motorcraft spark plug. This is not a factory. It would have been a Champion number 8, is what this engine calls for. This is not a Champion number 8, but it's an equivalent. It's a Motorcraft BR8. And you'll notice something peculiar about this plug. Now, this plug has been in this engine for maybe 30, 40 years. Something peculiar about this plug. Have you picked up on it yet? Anyone? Class? Okay. This plug has never been fired. This plug was installed in this engine probably 40 years ago in an attempt to get the engine running again. And they were not successful. Take a look at it. Never fired. So that's kind of interesting. In a big way. That is very interesting to see. So we're going to reuse this plug. We're not going to replace it. There's no need to. But what I am going to do, though, is I'm going to put it in the evaporust to get this little bit of corrosion off of it. And we're just going to soak it in the tank. But I want to take this this lead off. A pair of pliers, there it is. We're going to take this off the threaded post, because it shouldn't even be there. Yeah, take that off. It's a brand new plug, never fired. I'm not sure how the plug will take to the evaporust, but we're going to find out. I found a set of 2 Champion number 8s, which is, again, the original plug specification. They're like $30 for the 2, and they're like the last 2 left in existence. This engine, I'm telling you, there's a lot of parts availability issues for these engines. If this thing had no carburetor, it wouldn't be worth fixing. If I'm going to run down the list of parts that if they were missing or damaged, there would be no saving it. The carburetor. Good luck finding another one. I was lucky enough to find a new shroud. That was sheer luck right there. And the shroud is in pretty good shape. There's another one of these on eBay, I think, with a cracked or missing tab on the bottom. That's usually how they come, missing tabs. But just so many things that could have totaled out this motor just based on parts availability and rarity. It's incredible that I can save it at all. But there are some random parts out there for these, you know. I can get a flywheel. You know, I can get a flywheel with missing teeth, or missing fins. But anyway, the new spark plug lead is going to come with a brand new reproduction. I might actually end up saving this one though, just because it's original. I think it would be more rewarding to save this copper one, but we'll see what happens. What a beautiful motor, though, huh? I mean, it's not even halfway there. So the cylinder head, what are we going to do with this? I might actually send this out to a local shop. I'm going to try to find a shop that will be able to bead blast this or shell blast it, because I can't get in the fins. There's nothing I can really soak it in to restore it. It's a complex casting for its time. I'm really surprised that they did it this way. It's a very interesting design. The fins go all the way through, so it's really innovative. So what it does is, the way it's made, it has like an integral air guide. So the top is all part of how it guides air across for for complete cooling. I mean, the air gets blown in or sucked through. I forget which way it goes, but it comes in this way, or it gets sucked through this way and guided through this way, completely across. It's very, very advanced for 1937. You know, I can imagine this is a very expensive casting, and I would say it's probably a lost mold casting, meaning you can only use the mold once. A lot of carbon buildup. It's got this little, look at the combustion chamber. So the spark happens in this little chamber here. And unless that's so clogged with carbon. No, it's just very interesting. The combustion occurs initially in here and then crosses over into the... It's just a really strange little design. I've never seen this before in any. Just a very, very interesting design. Again, as we all know, the complexity of that head made way for what we have on basically every air-cooled lawnmower engine made ever since. And that's basically this guy here. This engine right here is based on a design that Briggs and Stratton pioneered in the early 50s. And it was in production in one form or another well into the mid-2000s. The Briggs and Stratton classic lawnmower engine, which was renamed a few times throughout its life, that engine used basically the same design principle as this engine here. It was discontinued only recently due to EPA pressures, and now... But Briggs and Stratton has really come a long way from this design, and then they've only fallen behind just due to market force pressure and cost cutting. It's all about cost cutting right now when it comes to building and designing lawnmower engines and small engines in general. It's all about saving money. This was all about making it happen. 1930s, 40s, 50s, it was all about building the best engine for the buck, and cost savings did end up being a result of that over time. Cost and weight savings. This is a cast iron block with a cast iron bore with a aluminum head. Oh boy. So yeah, this engine is this is gonna be a living room engine. It's gonna go in I'm gonna make a little handmade cart for it to sit on, a little platform, some wheels. It's gonna sit in the living room. We'll use it as a doorstop. Yeah. But she'll run. I'm sure of it. Oh yeah, she'll be a runner. So one thing we need to do, once we get the engine ready to fire, we're going to have to make some adjustments to the governor. Hey, governor! Got to make some adjustments to it. Yeah. There's a very little amount of range, very small movements. But that's how it goes together. I checked the book, made sure. We need to adjust the spring tension, that kind of thing. But yeah. There is supposed to be a screw here for the idle adjustment. I'm not really sure how that works. Because if this is idle, or this is closed, be backwards. But double check that. Unless I have this arm on backwards, and it's really supposed to be going the other way. And this is closed. Like, I don't know. I'll have to look at that, see if I got it right. But there is supposed to be some kind of an adjustment screw here, as far as I know, for idle speed. And it just doesn't look right to me. Something ain't right. something isn't right. Well, we'll figure it out. We have all the time in the world. It's not the, yeah, we'll figure this out. I might put a little bit of sealer in these joints here, just to make sure there aren't any vacuum leaks. Something tells me that there probably will be. But, yeah. It just doesn't make any sense. And where does the throttle hook up? That's what I'm trying to figure out. Where does the throttle... There was no throttle in this engine when I got it, so where does that hook up? I can't figure that out. So unless this engine was designed to run at a fixed speed and had no manual throttle controls, that would make sense. That would make a little bit of sense, I suppose. So, alrighty guys, that's it for now.